In this video, I will provide you with roof framing suggestions, no wall framing or any other structural suggestions, just a few ways that you can build a larger or wider building, especially a garage. I've been getting a lot of requests for this video. And if you do need more information on how to build a larger building, feel free to let us know in the comment area. And I might make a video series on how to build a variety of different sized garages or buildings with conventionally framed roof rafters that would not have engineered trusses in it. So what we have here is a 30-foot wide building with 2x6 rafter ties that lap in the middle. And the rafter size is irrelevant here. You're going to have to check with your span charts or your engineers or local building authorities and contractors to get that information. And in reality, a 30-foot building can probably be built with larger roof rafters than 2x8 or 2x6. And for those of you wondering how I'm getting the roof rafters to line up at the top and the rafter ties to connect to the same side, I'm just simply angling the rafter ties. And that's not going to be difficult to do in this long span. And of course, the rafter ties will lap, and I believe a 4-foot lap would be sufficient with about 10 16D nails on each side. And the rafter tie will be held up by a 2x support, 2x4 that will nail into the ridge or the roof rafter. And you can see here where I rotated this one 90 degrees from this one, and we'll let you choose which one is going to work better for you. Because in a situation like this, we're going to be nailing this support brace into the ridge and then end nailing this 2x4 rafter tie into the brace, or toe nailing the brace into the rafter tie. And this is another question I get a lot. A lot of people think that this brace right here is helping to support the ridge and is only used to hold up the rafter tie to prevent the rafter tie from sagging down, especially in longer spans. And if that doesn't make sense, you need a little more information on that, let us know in the comment area, along with any other questions you will have about this particular framing. And of course, your collar ties, a 2x4 will do, a 1x6 I believe will do. And the collar ties, along with the rafter ties, cannot be spaced more than 48 inches on center. However, you would need to check with your local building codes to verify that information. And in our next example, what most of you have been waiting for, how to frame a conventionally framed roof using construction standard lumber and no engineered trusses in wider buildings. So here we have a 40-foot wide building. And we're simply going to install structural support beams in the middle of the rafters, the middle of the span here, middle of the span over here. And sometimes we will need to install a structural ridge beam that will be supported in the same way these beams are supported, with a post transferring the weight down to the building foundation, which might require a concrete pad here, something larger than your original footing. And the rafters will simply lap and fasten together with 16D nails. And I'm guessing you would use about 10 nails here. And no, 10 is not the magic number. Another thing you would need to check with your local building authorities on. And this realistically is the key to making wider buildings with conventional lumber. By reducing the overall span, cutting it in half sometimes, or even thirds, depending upon the width of the building and the materials used. And sometimes the rafter ties can be supported by the roof rafters using support braces like these. And for those of you who have been paying attention, you're probably wondering why we don't need rafter ties to go from one side of the building to the other. That's because we're using the structural beams. The structural beams will function in a way, when built correctly, to prevent the walls from spreading out, which is the main reason why we're going to be installing rafter ties. And if you install a ridge beam, you might not be required to install rafter ties. However, you might be required to install additional bracing to prevent the roof from moving in a variety of different directions. Last on our list, let's take a look at a 60-foot long building, and you guessed it, all we need to do is add a few more structural support beams along with some building hardware. I'm not going to be providing you with all the building hardware you're going to need in this plan. However, straps will be required to connect wall framing top plates together. And I do have more information on a variety of different things at our website if you need to look at it, along with strapping, structural bracing, collar ties, rafter ties, you name it. Head to the website, check out the roof framing section. And in the longer buildings, you will have rafters that will again connect to the other rafters and to the structural beams. And you will probably need some blocking in between the roof rafters. Here is another video in our large building series. In this video, I will provide you with two different ways to build the gable walls. However, the most common is going to be a flat wall, the same height all the way around the perimeter of the building. And that's going to be more for a convenience. It's going to be easier to build than building this over here. And don't forget that your engineered roof trusses are usually a system that is designed with a plan, and that plan will usually have installation instructions or examples, details on how to assemble the roof. And that system might not require a wall like this. So let's go ahead and take a look at the bottom of the foundation. We will not have any additional concrete footings in here. Another plus for a truss roof, plus the fact that they are usually easy to install. And with our balloon framed rake wall here, I will also provide you with two different ways to finish off the corners here for the roof rafters. And of course, I will provide you with the most common method, along with something a little more tricky over here where we're going to notch the rafter into the wall framing. And then our lookouts will be sitting in these notches here. And I don't know if this is a method that would be approved by your engineer because we're really cutting a lot out of the framing plate there. And our building is 30 foot by 60 foot with a door over here and a large opening over here for our garage door. And if you notice, I'm also going to provide you with two different ways to frame the header here. And I went ahead and used a 4x4 post there. The 4x4 post was part of my original design, thinking that I would need to install hold downs at each end. So I have a 4x4 here and a 4x4 here. And you might need to add more anchor bolts and hold downs to provide additional lateral support for the front wall here. And the other method here would be stopping the header at a king stud. And since the framing plates do not go through, we're going to need to install a strap. And you might want to move the strap over a little bit so that it is not in the way of the roof truss. Next up, let's go ahead and install our roof trusses. We will have a gable roof truss at this end of the building. And don't get confused, you don't need to frame it the same way here. Like I said, you can have a flat wall with a gable truss at each end to make your job a little easier. So we're going to have the top of the gable truss notched for our lookouts, or 2x4s that will be supporting the fascia board. And let's go ahead and take a look at the strap I was talking about. You just want to move it over a little bit so that the roof truss is not sitting on top of it. And this might not be the case all the time. If you have a large strap, then the strap is going to take priority over the roof truss. And our eave blocks here. And our block here for the fascia board. And basically the lookouts are going to provide us with enough structural support because this block will not be providing us with much. And this is another common method for framing with roof trusses. And we will need to install some support backing. These 2x4s will prevent the bottom of the trusses from moving. And in our example here, we will be installing two of them, basically spanned about 1/3 of the way. The building is 30 foot wide. And if we divided that by 3, we would have about a 10-foot space between the outside walls and each one of the support braces. And again, your roof truss manufacturing company will provide you with all of the necessary information you need to assemble the roof. And they're going to be the ones who will provide you with any additional information you need that might not be on their plans. Let's go ahead and install the fascia board. You can see here where the lookouts are going to be installed. And let's go ahead and take a quick tour of this for those of you who have not seen any of my videos. And of course, a view of the ridge block here for the fascia board. If you notice, the block in the center is not even at the top or flush with the top. It's down a little bit. The edges of the block will be even or flush with the fascia board and the truss. So make sure that you pay attention to the assembly of these blocks here so that you don't end up with a bump up there in the sheathing. A view of the other side there. Let's go ahead and take a look at how we added this board. We're just simply going to add a board and nail it to the rake wall here. However, when we do that, we're not going to end up with a rafter that will be even with the outside edge of the wall. And this looks kind of funky sometimes, so only use this method here if that's going to be acceptable. And of course, the lookouts here will attach to the lower top framing plate and will be notched in between the upper framing plate. And you can always have two top plates that run all the way through and then some blocks like this. That would be acting as a third plate basically. Now let's go ahead and head over to the other side. Take a look at how we notched this rafter into the wall framing so that it would be even with the outside edge of the wall. And like I said, this usually becomes a problem when you're looking at the bottom of the eave. So something like this seems to look more normal than the other side of the building, especially to those of you who are in the business. So after we install our roof sheathing, this is what the bottom of it would look like. And of course, since it is a gable roof, it's going to be easier to install the roofing because you're not going to have as many cuts as you would on a hip roof. And of course, here is the detail I'm talking about, where this kind of looks a little goofy. You might have stucco or siding that's going to go up here and create some type of an odd looking corner. And again, if it's not that big of a deal and you need to build a large rake wall instead of using a gable roof truss, then I would say go for it. Use that method. And you might need a block here in the wall to nail the bottom truss cord spacer to. And if you have it up against a wall framing stud, you will be able to attach it to the framing stud and the block, and attach the block to the framing studs on each side. And if you notice, we do not have any drywall backing. You can always attach this to the drywall backing if you're going to be installing drywall in your garage. Front view of the building. Let's go ahead and take a look at the bottom here. And one of the biggest problems you're going to have with this roof is that you won't have the height that you will in our previous examples if you need it. So we have a 7-foot opening, 7 foot off of the floor. And if you're going to be parking large equipment in your garage, this might not work. And you're going to have to forget about this design here. This design right here should work fine for vehicles like a car or a truck and storage, but you're not going to be able to park a large tractor in something like this if that's what you need this garage for. In this video, I will provide you with something to think about when designing before you build a large building. And that's going to have something to do with the final length of the building. And what I would suggest would be to build a building in 2 or 4 foot increments, and preferably 4-foot increments. And what we have here is the building that I previously did in this series on working with designing and framing large buildings, where we have 3 16-foot beams and then a 12-foot beam to create our 60-foot long building. And of course, I'm not about to suggest that you change a design that you like to fit this, just something to consider, and definitely something that I consider on almost every type of project I work on. And in some situations, if your beams are the right size, they're exactly 16 feet. They're exactly 12 feet long. Then you won't have to cut these beams either. And if you don't have a large beam saw, when dealing with some of the larger lumber, this could actually be another benefit. So let's go ahead and move the wall in 12 feet to make a smaller building and something that will have 3 16-foot beams in it. And let's go ahead and finish off the exterior of the building just to provide you with what a building would look like. That's 48 feet long and using equal length structural beams along with a longer building. Again, all I'm doing is using the same length beams, same length posts to determine the length of the building. 80 feet and not 79 feet or 77 feet where I might have additional waste, unnecessary waste that could allow you to get a few more feet. Now, I'm not suggesting that you're not going to need more concrete, you're not going to need more lumber or more roofing materials, but I am suggesting that you might be able to pick up a few more feet or reduce the length of the building a few feet to make something like this fit into your budget a little better, or provide you with more square footage, whatever is going to work better for you. Here is another one of our large building videos. We are building a 30-foot by 60-foot garage here, 30-foot by 60 foot. 6 individual footings to support the posts that will be supporting the beams that will be holding up the roof. And I'm going to go ahead and take the building apart like I normally do, except I won't be spending a lot of time taking the building apart like I normally do, but I will spend a little more time putting it back together. So here we have our 2 outside walls, 16-inch on-center stud spacing. And make sure that you lay the studs out for shear panel or plywood sheathing if you're going to be using it. And in this video, I don't have any anchor bolts in the foundation. You will also need anchor bolts. And I say that, but in your area, you might not need anchor bolts. And we will be using 2x4s. You can use 2x6 or larger wall framing studs, especially if you need to install thicker insulation. And don't forget to lap the top framing plates at least 4 foot. And I really don't care if this is a building code in your area or not. It makes more sense to get a stronger lateral connection, side-to-side movement. If this thing starts pulling in one direction and you only have a 1 foot lap here, well, it won't take a rocket scientist to figure out that the wall could actually rip apart at the top plates. And this wall here will be the same as the one on the other side. And I would imagine the layout would be the same also. However, our front and our back wall will be different. I went ahead and I framed this for a larger opening, and I believe it's about 10 foot by 10 foot, and then I put a 32-inch wide door in the back. And you can always install a door over here or anywhere along these walls using the same method. And of course, our mid-span blocks and the pockets for our beams that will be supporting the roof. And it wouldn't be a bad idea to strap these 2 beams together, this beam to the beam that's going to be running in this direction, along with strapping the top plates together. Put a strap wherever you have a break in the top plate framing, and that might include up here also. And of course, I'm using the word might because in your area, you might not need a strap. However, here in California, we need larger straps and of course, more of them. Now, I went ahead and shaped the top of the framing plate here, and you don't need to do that. I'm just kind of throwing out a few more things that you can use on a project like this or other projects if it will work for you. And of course, the reason for shaping this will be that the ridge will be sitting on top of it. And if you need to make the door wider, you're not going to really have a problem with this design. Just simply move the post over a little bit. Next up, let's head over to our back door. And you can always add more doors or windows around the perimeter of the building if it's going to work better for you. And of course, a strap that we're using here to connect these 2 corners together to create a nice structural connection there. And in this case here, we needed to add an additional block underneath the top plates so that we could get additional nailing for the strap there. View of the back wall. Let's go ahead and install our post and beams. And don't forget, we are going to have a seat cut for our rafters here. The beam will need to stick up a little bit. And an example of how you can use a strap to connect the top plates together. You can always install 2 straps if you would like, but 1 will probably do just fine. And I cannot provide you with the type of strap or the length of the strap. However, I can tell you that straps are used to connect things together like this beam here, when the post-to-beam connector might not provide you with enough structural strength. Don't forget, you're going to be getting additional structural strength from the roof sheathing also in a situation like this. And of course, our post-to-base connectors, and again, I like to have them up off of the concrete just a little bit, or have the concrete even with the bottom of the connector. Let's go ahead and zoom out, take a look at the beams. Now, I do not have the beams equally spaced. I believe I have a 16 foot, 16 foot, 16 foot, and about a 12 foot. You could always space the posts out equally if that's going to work better for your project. Let's go ahead and install our lower roof rafters. And I think I'm using 2x6 in this video, and we have about a 10-foot span here. You might need to use larger roof rafters if you're dealing with snow loads. And of course, our blocking and our seat cuts. Don't forget that I do have other videos in this series you can watch, and I've already done a series for building a variety of different garages in another one of our playlists, so make sure that you check those videos out also. If you're interested in building something like this side right here or the left side is going to be the same as the right side if the beams are located in the same spot, the same distance away from the outside of the wall to the face of the beam or this side of the beam, and the same on the other side. Let's go ahead and finish the roof framing with the top section where our rafters will be lapping, and we will shape the tops of the blocks to provide us with some better nailing from the roof sheathing into these blocks. And I believe these roof rafters are spaced 24 inches on center. And of course, the reason why I shaped the top of the wall framing there, you'll get a better idea over here. You can see where the shaped section of the ridge is sitting on top of the wall framing. Give you a better view of it there. We notched the ridge so that it could sit on top of the flat section in the wall framing. Next up, let's go ahead and add our outlookers and the fascia board. The outlookers will notch into the roof rafters sitting on top of the gable wall here. And it wouldn't be a bad idea to space this roof rafter accordingly so that you can get some structural support from the cantilever here. In other words, don't have a roof rafter 6 inches away from this one here or 10 inches away if that won't work for your cantilever. So the fascia board here is 2x8, I believe, along with our roof ridge. And let's go ahead and wrap this video up by installing our roof sheathing. And as always, if you have any questions at all, feel free to leave them in the comment area and I will answer them as soon as possible. And of course, this video would not be complete if I did not throw in that you might need to check with your local building authorities for lumber sizes, building hardware, and everything else you might need to frame and build a 30-foot by 60-foot building in your area. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.